Hello and welcome. Starting today, I'm launching a brand new Databricks Weekly Update series where I'll be covering the latest and greatest updates from the Databricks ecosystem, including new product launches, feature enhancements, and important announcements. Last week, Databricks rolled out some high impact and exciting updates that could directly affect how you build, deploy, and run your workloads on Databricks. And if you are a data professional or a Databricks practitioner, these updates you definitely don't want to miss out. So please watch this video till the end and let's get started with what Databricks launched last week. First thing first, I'll first list out the announcement that Databricks made, then I'll dive deep into each one of them and explain you what that really means for you and your company. All right. So the first announcement was Databricks Lakehouse. Now, Databricks Lakehouse is now generally available on platforms like AWS, and it will soon be available on Azure and GCP. So that was the first announcement. And the punchline from Databricks was, while announcing this product or while making this product in GA, was stop fighting infrastructure, build intelligent apps with serverless Postgres for humans and agents alike. I'll dive deep later on and explain you what this really means and how this architecture from Lakebase is different from traditional databases like Oracle and SQL. All right, so let's move on. That was the first announcement. The second announcement was this one: data quality monitoring at scale with agentic AI. So, uh, Databricks announced this capability, which is in public preview right now, and this capability is built on Unity Catalog to detect data issues early and resolve them quickly. Okay, and again, I'll dive deep into this later on and explain you what this really means. And then third and last but not the least is this one: Cloud A Opus, which is the latest model from Anthropic, is now available on Databricks. Okay, so these are the three announcements. Now, before I deep dive into each one of them, a quick note: if you're looking to learn Databricks in a structured way and right from the basics, then I have launched a brand new Databricks Architect Zero to Hero course. The introductory video for that course is out, and you can see the link of that video on top right hand side of your screen. Please go ahead and watch that, and stay tuned for more video in that series as well post this video. Right, so moving on. So let's start off with Lakebase. Right, so as I said, Lakebase is right now generally available on AWS, and it's in preview beta on Azure, and it's coming soon on Google Cloud. And when it comes to the compliance and security certification, SOC 2 and HIPAA are on the roadmap for early this year. Okay, now let's look at the problem that Databricks is trying to solve with this Lakebase. Okay, now the problem with traditional databases has been that the compute and storage is very tightly coupled. Okay, and because of this, the scaling becomes a bottleneck. If you want to scale your storage, you need to scale your compute as well. So there is no independent scaling because of this tight coupling of compute and storage. And also the another reason is the resource conflict. So queries compete for fixed CPU memory. Because of this tight coupling of storage and compute, there is a resource conflict as well. And also, there is a there another problem that database is addressing here with Lakebase is that it's removing these data silos. So traditionally, OLTP, the databases, that is online transactional processing databases, and OLAP, that is online analytics processing, have been two different systems. So if you need to make sense of your data that's there in OLTP databases, you would need to do ETL and bring it on OLAP. Now, because of this, data silos exist, and that's another problem that Databricks is has solved with Lakebase. That uh, with with Lakebase, both these things come together. There is no ETL required, and analytics can happen on the fly. Okay, moving on. So that was the first thing. Now let's look at the architecture. As I said, the compute and storage have been decoupled, as you can see here, and both of them can therefore independently scale. And second thing is, what's behind the scenes. This lake base is based on Postgres 17 database that's open source. Okay, and that's another thing. So and moving on, As I said earlier, this lake base breaks the silos and it unifies apps and analytics. So data shared storage for data lake acts as a stage storage, and you can do both analytics and your transaction queries on your lake base. So no ETL required. Operational data is immediately available for BI and AI. Okay, again, diving deep again here to the to the architecture of Lakebase is this. As I said, stateless compute. Since compute and storage are decoupled, there is no lock-in, and therefore there is lower CTO, lower total cost of ownership is also less. Um, Another thing, and then moving on, another important feature this particular Lakebase has got is it's a true serverless, right? It auto scales when there is a spike in the IO transaction, and then it scales down to zero when there is no demand, or there is no traffic, and then it scales up if there is a traffic on your database. So you only pay for what you use, spins up instantly, shuts off when idle. Another thing is, so far developers are used to branching or cloning the code. But what if you want to test your database? So cloning the database or branching the database has not been possible so far. But with this lake base, what Databricks has done is, you can essentially clone, or like the way you clone your code, you can clone your you can create your own branch of database and test out. So it's like it based on zero copy technology, so it can create isolated zero copy clones in second. It's safe for testing without production risk. So that's another feature with this. And another important thing with Lakebase is this, that it's built for AI agents. Look, AI agents want a separate environment, an isolated environment, so that they can experiment their stuff, and then they can, if it succeed, well and good. If not, it can go and do point in time recovery. So that's what it is. So again, leveraging this branching technology that I shared in the previous slide, Lakebase can branch your database, and then AI agents can branch your DB and then run experiment. If it succeeds, well and good. If it fails, it can rewind. So elasticity launch thousands of agents, resilience milliseconds level undo, isolation no deterministic testing. Okay, and also Lakebase is unified with Unity Catalog. So Unity Catalog acts as a governance technology over here. As you can see, Lakebase and OLTP and OLAP both sit under the umbrella of Unity Catalog. So with this, there is one security model for entire state, be it OLAP or OLTP. No separate access controls, consistent auditing and compliance. So what's the impact with this? So what the real impact so far we have seen is, as Databricks says, that there is a company called Hafnia. They've gone from 2 months to 5 days. So they reduce time to deliver production ready apps from 2 months to 5 days, and then EasyJet from 100 to 2 repos, and then 9 months to 4 months dev cycles. So Dennis says what once took months is now delivered in a fraction of the time. Okay, so the impact of the lake base has been huge, and hopefully it will be huge in the future as well as more companies adopt it. Okay, so in conclusion, the tagline from Databricks is this: when it comes to Lakebase, stop fighting for infrastructure, start building. They're serverless, scales to zero, auto scale, agile, instant branching, zero copy, and it's a unified one platform for apps and AI. What I personally believe is that yes, this particular offering is great indeed. Because it brings both your OLTP and OLAP together, and the compute and storage has been decoupled, like the way it's there for Lakehouse as an Lakehouse architecture. So definitely, and then the fact that you can definitely copy your or zero clone your entire DB is, I think that's huge. Okay, so moving on to next update or next announcement that Databricks made was this, that agentic data quality monitoring. And their tagline here is, this is built on Unity Catalog to detect issues early and resolve them quickly. All right. Look, the point here is, data quality is of high importance to companies right now, because if you want to train your AI model, your data should be of extremely high quality. It's like garbage in, garbage out. If the data is bad, then you'll get bad output from your LLMs. So data quality is of paramount importance right now. That's what, to address that, Databricks rolled out this particular feature, and you can see on your screen. This is how it looks like in Databricks Workface. You can see that in Unity Catalog. You can see this data quality monitoring solution, and if the data is not good, it would show unhealthy, unhealthy, unhealthy here. All right, so moving on. What does it mean? What this means is, as I said, data data states in the companies are growing exponentially because of AI and analytics. But then the way, or the tools that we have at our hand to make sure that the data quality is great are not so good, and that risk is a gap that introduces blind spots and unchecked tables, and that's what Databricks has tried to address here. So the failure of manual rules right now is, rules are defined once, data is fluid, right? Rules are defined once, um, right now, but the data is fluid, it keeps on changing. And then this is unscalable as well. Custom checks cannot cover millions of tables, right? So the data state is growing, but then the way or the tools that we have at our disposal to check them are limited. And also, the moment a rule is written, it begins to rot, because the data state or the data patterns keep on evolving and keep on changing. That's the reason Databricks has introduced this agentic intelligence, which says, moving from static thresholds to AI agents that learn normal data patterns and adapt to change continuously. And as you can see, pattern versus threshold, agents understand seasonality. They know data volume dips on weekends or spikes during tax season. So they learn it from patterns and threshold. And then the intelligence scanning. So you can there are two ways that you can do scanning. One is at schema level, monitors all critical tables without manual config. Smart frequency scans frequently used tables, often skip statics or deprecated tables automatically. Okay, so there is a schema level scanning, and then there is lineage driven prioritization as well. So these agents track the lineage. So issues are prioritized using Unity catalog lineage and certified tags. It fixes the root cause, not just the symptoms. And so, as I said, there are two methods through which this is currently working. One is anomaly detection, that is learned behavior, automatically monitors freshness, completeness, and volumes, and adaptive, no manual rule required with this. And then there is another thing called profiling, data profiling. It captures summary statistics to track changes over time. These metrics feed the anomaly detection engine. All right. So the resolution leap, deep integration with database platform, trace issues directly to upstream lake flow jobs. So i- since it's deeply integrated with database platform, it can tag the lineage, and then if something goes wrong, it can detect and tell you right away. Okay, and then there is universal hand indicator, a unified signal for the whole organization. Customers instantly know if data is safe to use. Okay, and there's a dashboard as well, as I've shown before. So what's the real world impact with this? So monitoring, Jake from Elinter Energy says, monitoring all our tables with a hands off, no configuration approach. Instead of users reporting issues, our data flags it first. So with this, this has really, without end customers saying the data is bad, the agents or AI agents are flagging it right now. And Amit says from one page, we can catch issues early, ensuring accuracy in our analytics and ML models. All right. So what next? So right now it's phase one. The rules that it's covering are freshness, volume, schema. In phase two, it will check advanced rules such as null, unique, and automated root cause. That's in progress. And phase three will be auto quarantine and filtering. All right. So in conclusion, it's agentic monitoring. AI agents monitor this and they flag it when they see issues, and this has really elevated the landscape of data quality monitoring. And then holistic health, then it's platform natives. So no manual rules, full estate view, deep Unity catalog integration. All right. Coming to a third announcement, the announcement or the embedding of Claude Opus 4.6, that is Anthropic's edge model on the Databricks platform. So what you can really do with this? With this, what you can do is build domain-specific agents with Agentrix, run complex analysis from SQL and Python with AI functions, automate workflows across documents, spreadsheets, and internal data